Exercise D1, Linear Growing Patterns. 1. For each of the following pattern, complete the table and state the pattern rule. 1A, so by counting the tiles in each position, we have 1, 2, and 3. To come up with the pattern rule, we need to know the first difference. So you take 2 minus 1, so we can see that the number of tiles in the pattern is increasing by 1. In our lesson, we learned that the rule will become y equals 1 times x. So the simplified way to write the rule is y equals to x. B. So take a look at the pattern. It will help you if you try to circle the patterns that keeps on repeating or being added each time. So position 1 has 5 tiles, position 2 10 tiles, position 3 15 tiles. Each time we go up a position number, the number of tiles increases by 5. Therefore, the pattern rule is y equals 5x. Number 2. Determine the pattern rule for the pattern represented by each table of values. So here we have position numbers 1, 2, 3. The number of tiles are 12, 24, and 36. These number of tiles increase by 12 each time. So 12 times x gives you the pattern rule, or y equals to 12x. B. So in this table of values, the number of tiles increase by 5 each time, from 5 to 10 to 15. And we notice 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So we know the pattern rule is y equals to 5x. Question 3. Predict the number of tiles needed for position 5, 10, and 90 in each pattern. It will be convenient if we know the pattern rule. So question A. Number of tiles equals position number times 8, or y equals 8x. For position 5, the number of tiles will be 8 times 5, 40. Position 10 will be 8 times 10, 80. Position 90 will be 8 times 90, 720. B. This time we have to think of how the pattern is increasing. So pattern 1, there should be 3 trapezoids. Pattern 2, I have 2 rows of 3 trapezoids. Position 3, I have 3 rows of 3 trapezoids. So there are 3 tiles, 6 tiles, and 9 tiles. The pattern rule is 3x. We have 3 times 5, 15, 3 times 10, 30, and 3 times 90, 270 in positions 5, 10, and 90 respectively. Question C. Pattern rule is y equals 10x plus 12. So every time we multiply 10 to the position number plus 12. So 10 times 5 plus 12 is 62. Position 10 is 10 times 10, 100, plus 12, 112. Position 90, 10 times 90, 900, plus 12, 912. D. This time, the position number and number of tiles are shown in a table of values. We need to figure out how much the number of tiles are increasing by from one position number to the next. So 12 to 23 is add 11. From 23 to 34, we add 11. So the basic rule here is y equals 11 times x. But we also notice 11 times 1 is not 12. 11 times 2 is not 23. 11 times 3 is not 34. But every time after you multiply the position number, we need to add 1 to get the number of tiles. Therefore, the actual pattern rule is y equals 11x plus 1. For position 5, 11 times 5, 55 plus 1 is 56. Position 10, do the same thing. Position 90, you do the same thing. Question 4. Guess the pattern rule from the pattern given. We can circle the pattern that you see that keeps on repeating or being added each time. So this upside down T shape is added to the subsequent position. And in pattern 1, the part that is not added each time but stays the same is the square tile at the bottom. It's right here, here, and here in each position. So I know that the number of tiles is going up by 3. So it's the multiplier y equals 3x plus the constant tile 1. So the pattern rule is y equals 3x plus 1. A. What part of the pattern represents the multiplier in the pattern rule? The constant first difference, or you add 3 tiles each time, shows you the multiplier. B. What part of the pattern represents the constant in the pattern rule? It's the fixed tiles, or the 1 tile at the bottom. C. How many tiles are in position 20? Well, knowing that the pattern rule is y equals to 3 times position number plus 1, the number of tiles in position 20 is 3 times 20, 60 plus 1, so 61. If you had 100 tiles, which position in the pattern could you build? Well, we know that in total there are 100 tiles, and this is equal to 3 times position number plus 1. We will try to solve this equation. So let's get rid of that constant first. So we have 99 tiles in groups of 3, and divide 99 by 3. X is equal to 33. Number 5. Guess the pattern rule again. So here is a picture for positions 1, 2, and 3. Which tiles are always there, and which part of the pattern is increasing, and by how much? There are 3 tiles that are always at the bottom, so we know that's the adding part in the pattern rule. And then look at the dark tiles. Position 1 I have 1. In position 2, 2 dark tiles. Position 3 there are 3 dark tiles. So I know that we're going up by 1 each time, which makes the pattern rule y equals x plus 3. There would be blank number of tiles in the 100th position because, so we can use the pattern rule to help us calculate this answer. Y is equal to 100 position number plus 3. So therefore we know there are 103 tiles in this position. Describe what the 36th position in the pattern rule would look like. So in the 36 positions, just like the other positions, there should be 3 tiles at the bottom, and then the number of dark tiles matches the position number, so there should be a column of 36 tiles. C. Could you build a pattern with exactly 104 tiles? Why or why not? Well, we set 154 equal to the pattern rule x plus 3. Subtract 3 from both sides, I get x equals to 151. And remember, x represents a position number. Is it possible to have position 151? Absolutely, because there's no decimal, there's no rounding, so it is possible to form a pattern with exactly 154 tiles. Number 6. Sean records the height of a plant each day for 3 days. Plant growth over 3 days. This is the table of values that shows this information. So on day 1, the height of the plant is 2 centimeters, day 2, 4 centimeters, day 3, 6 centimeters. How tall will the plant be after 10 days if it keeps growing like this? When we take a look at the first differences, we notice the height of the plant keeps increasing by 2 centimeters every day. And this suggests that we can come up with a pattern rule for the plant height, which is y equals to 2 times x. We can quickly check to see if there is an adding part to this pattern rule by backtracking the height. So if I go to day 0, what will the height be? We go back 2 steps, the height will be 0. So there is no adding part. So on day 10, we use 10 as x. So 2 times 10 is 20. So the plant will be 20 centimeters. The answer is D. 7. Michael is building a tower out of Lincoln cubes. The number of cubes he uses is represented by the equation T equals 8n, where T is the total number of cubes and n is the number of layers in the tower. How many cubes will Michael use if he builds 36 layers? So go back to the question, because we have information about how many layers we have and which letter in the equation refers to layers. Well, we can see that n is the number of layers in the tower, so n must be 36. So use 36 as n in the pattern rule, multiply 8 by 36, you get 288 cubes. Answer is D.